Look at these problems, okay? Note it down and do not be afraid. Do not be afraid of this problem. The problems as such are very simple. The problems as such are not very difficult. All of them can be solved by whatever we have done till now using those concepts only. Okay, we do not collect too many concepts and too many theories. Okay, we learn one theory, we learn one concept. It's like a tool. I have one tool, I'm expert in that tool. Chances are most of the problems I'm going to solve using that tool only. Okay, do not collect too many tools. You become expert in few tools. That is more like important thing than having too many tools and becoming jack of all trades but master of none. It's like that. You understand one tool, you understand one concept, one theory, understand it properly, thoroughly, completely. That is going to help you. Okay. Here, what is the concept? Till now, we have been solving all of the problems, most of the problems using this concept only. What is that concept? The concept is like this: is apparent distance d dash is either d over mu or mu times d. We are going to make use of this thing only. That's it, and we are going to solve every problem here using this only. This is what we have been doing. In the last class we did it. This class we are going to do it. Okay. Now, for a flat surface, of course, for a flat surface, okay. If we remember some relations, some formula, equations, we also remember the conditions under which they are applicable. Okay. For a flat surface, of course, we are doing flat surface, and next class we are going to start curved surfaces. Okay, reflection from curved surface. For a flat surface and one of the mediums is air. We do it this case only. That's it. Once you become expert in this, you can handle the other cases also. We have the basic tool. In the beginning itself, we developed the theory. So you become confident in this, that also you are going to handle. Okay? Don't worry about that. So here, let's see. So I have this concave mirror. Try to understand how we are going to solve this, especially the logic. The logic is a very, very nice logic, okay? Beautiful logic here we are going to apply. This is my concave mirror. Concave mirror. Water is filled in the mirror. Water is filled. And I have this object. You see, it is not mentioned. It is not mentioned here, but it is here. It is here on the principal axis. Okay. It is not specified. It should have been specified. It should have been specified. It is on the principal axis. It's placed symmetrically on the principal axis. Okay. This thickness here. This thickness we have to ignore. We are going to ignore this thickness. The question is find t. That means at what distance above this water surface I should keep my object such that the final image coincides with it. The final image coincides with it. We did few problems. Remember this term, coinciding, final image coinciding. That happens only if the ray starts retracing from some point. Only in that case it will happen. Okay. When at some point the ray starts to come back following the same path, then it will reach the object. When light ray starts to retrace, it retraces its complete reversal. It retraces its complete path. It never retraces this part of a path. No. The complete path, complete reversal. Okay. And that is going to help us solve this. It's like this. I have this object, light rays start, one light ray is here. Let's take one light ray. It hits the water surface normally like this. It goes to the mirror without deviation. Without deviation, because this is normal incidence. And then from the mirror, it will start to retrace. This will retrace, to go back, because this is passing through the center. It is passing through the center. Okay, do you understand this? Understand this? Now, let's take one other ray. I want to locate the image. So I need at least two light rays. I need at least two light rays to locate the image. Now this light will bend. This light will bend. Okay. It will bend like this. That's how the light ray is bending. It's bending like this. Okay. If I do not have this water, the light ray will directly reach mirror, and then image will be created according to the object distance. Okay, we know how to find that. Because of water, the light bends. What this mirror will think? This mirror here, the concave. Think about the concave mirror. It is receiving these two light rays. What the mirror will think? These two light rays are coming from where? They are coming from here. If I extend it backward, the light rays, both light rays appear to be coming from this point here. This point here. Now, if I want my final image, to coincide with the object, the light ray has to retrace. Under what condition a light ray retraces its path? A light ray is incident on a concave mirror. Under what condition it will retrace? On a mirror, it is going to retrace if it is normal incidence. This is normal incidence because the light ray is passing through center. The center is going to be somewhere on this line. So this light ray is already passing through center. Now, if this also appears to be coming from center to the mirror, this is the mirror. If this mirror thinks, if for this mirror, if this light ray appears to be coming from its center, then the light ray will retrace. It will retrace. And whenever the light ray retraces, it retraces its complete path. Okay? It will retrace here and it will reach back to this point. This is where I will get my image. Provided this point should appear as center to this mirror. Okay? In that case, what will be this distance? This distance will be equal to radius. This is d dash. This is the apparent distance d dash is equal to radius is equal to 40 centimeter. 40 centimeter. Okay, so what should be this height? This is d. Now d dash is more than d. It will be mu times d. Okay, so here I have d is equal to d dash over mu. What is d dash? 40. This is 40 over 4 over 3. It becomes 30 centimeter. This is my answer. This is our answer. That's how we solve it. Answer is 30 centimeter. Not much calculation, only logic. Only logic. Using the simple tools. If you know how to use that tool, you know how to solve a problem. Okay. Now the next, can you find the next one also? Can you solve it? Can you solve the next one also? What do you think? Okay, next one. Next one. Water is filled in this container. At the bottom, I have a concave mirror. I have a concave mirror. Radius is given 40 centimeter. Okay. Different heights are given. Different heights are given. Okay. First, what is height? Height up to which water is filled. Okay. We have to ignore this thickness here. This thickness we are ignoring. In the last problem also we ignored the thickness. Okay, this thickness we have to ignore. Okay, question is, at what distance from water surface rays will focus when seen from air? Let's look at what happens when I have only mirror. That's only mirror. Light rays are parallel. After reflection, what will happen? All of them will focus. All of them will focus. Where? At the focus. All of them will converge at focus. Okay. This is my principal axis. This is my principal axis. Okay. Let's look at this way. This is my principal axis. Principal axis. Okay. Light ray. I have this parallel beam of light. What we are doing? First we are trying to understand what will happen if there is no water. Then we will bring in water. Okay. First you try to understand what will happen without water. Without water, all of these rays are going to focus, going to converge at focus. That's where it is going to converge. Let me write it like this. Let me draw it like this. That's where all of the light rays are going to focus here. This is focus. What is this distance? This is 20 centimeter. Okay. Now what will happen? So if my observer is here, if I am looking from here, I will see all of the light ray focusing here. Now let's start filling water. First case. I fill up water up to 30 centimeter. Okay. This is 20. I am filling up water up to 30 centimeter here. This is water surface. This is 30 centimeter. Okay, 30 centimeter. Now I am looking from outside. So now these light rays, now they cannot directly reach this observer. Now they are going to bend. They are going to bend away from normal. Okay. Now to this observer, light rays will appear to be coming from here. This is the new focus. This is where the light rays will focus apparently for this observer. Now, so for this observer, this becomes actual depth. Okay, and here this becomes the apparent depth d dash. It is going to be equal to d over mu. It's obvious from this ray diagram. It is going to be, what is d? This is 20, this is 30, so this is 10. 10 over, what is mu? Water. 4 over 3. It is going to be equal to 7.5 centimeter. 7.5 centimeter. Do you understand this? 7.5. That's where this is a 10. I hope I'm doing it all right. 10 over 4 over 3. This is water. So 7.5 centimeter. This is the answer. At what distance from water surface? 7.5. The rays will focus when seen from air. First case. Understood? Second case. 20 centimeter. I'm going to solve it here itself, in this figure itself. Second case. So forget about all this. Second case. I am filling water up to where? I'm filling water up to, okay, it's like this. I am filling water up to what distance? Okay. Right where the rays are focused. Right where the rays are focused. Right up to the point where the rays are focused. I'm filling water up to 20 centimeter. Looking from outside. Okay, I'm looking from outside. Now this rays after refraction, I do not have, if I do not have water, they will continue in this direction. And when look from outside, they will appear to be focused here. But when I have water, in that case also the rays will divert. The rays will divert, they will bend away from normal, but still they will appear to be coming from the same position. Okay, from the same position. Do you understand this? Answer is going to be 0. The light rays are actually focusing on the surface, right on the surface. Okay, if someone is looking from outside, so at this point here, where the rays are focusing, if I do not have water, the rays will continue in this direction. Okay, and if I have water, the rays are going to diverge like this. Okay, they will, both of them will bend away from normal. But then in that case also, they are diverging from this point. They will appear to be coming from the same point, whatever is the actual point. Okay, and then, okay, so answer will be 0 on the surface. Now the third case, 10 centimeter. Okay, let's look at the third case. Okay, it's like this. Third case can be a little confusing. Okay, if you apply too much theory, it will become confusing, you will have problem. You apply only those simple tools, that's it. Okay, do not apply too much. Do not think too much. Okay, when you start thinking too much, that means you are making some mistake. Okay, it should be a straight line motion. Alright. Now, mirror. This is my mirror. This is my mirror. Light rays are focused here. This is my light ray. They are going to be focused here. Let's say that this is my focus. Okay, I am drawing this figure. This is my focus. That will happen if there is no water. Now I am filling water. This distance here is 20 centimeter. 20 centimeter. Now I am filling water up to this point. Clearly, I don't really have to explain. Clearly, what is going to happen? Okay, the rays, first of all, they can never reach this position. They are going to diverge. They are going to diverge away from normal. This is my normal. This is my normal. This is my normal. Okay, and this is my actual distance. This is my actual distance. If I do not have water, the rays will meet here. But if I have water, the light rays are going to diverge. They are going to deviate. Okay, they are going to bend away from normal. They are going to bend like this, and here also they are going to bend like this. Okay, that's where the rays will now focus. Okay, this point will be F dash, and this for us is D dash. Clearly, here also D dash is equal to D over mu. D dash is smaller than D. It is going to be D over mu. That's it. This is 10 over 4 over 3. This also is 7.5 centimeter above the water surface. The rays will focus. Okay, got it? Now the next one is a general problem. Before we solve it, let's discuss, let's kind of develop some little theory. Okay, all of that is going to be used in these problems. Okay, one small theory is like this. Okay, let's say that, so what we are going to do, if you want you can solve these problems, it's not a problem. Of course you can do it. Do you think I can stop you? I cannot stop you from doing whatever you want to do. Do it, try to get the answer, that's fine. But before that, it will be better if we discuss one small piece of theory. It's not a theory, we are just going to use whatever we know. I'm going to derive some important result. That's it. Not a theory, not a new theory. It's like this. Very simple case. I have this slab. Okay. Now let me make my slab here. Let's look at this. I have this slab and I have an object here. I have my object here. This is my object. This distance is d, distance is d, and this is slab, thickness is t, the refractive index is mu. Thickness of the slab is t, refractive index is mu. I have one observer here and one observer here. Two observers. Where this object will appear to both observers. That's what I want to find out, and that's what in all of the problems we have to find. Okay? Let's try to figure out. Best thing, ray diagram. Optics, this is the chapter on ray optics. Geometrical optics is ray optics. See a problem, start thinking in terms of ray diagram. Okay. I want to locate its image. I need at least 2 light rays. Minimum 2 light rays I require. So whatever is suitable I will take. Okay. Let's take one light ray which is incident normally. Normal incidence. It will pass without deviation. Undeviated it will pass. There is no deviation. Okay. First light ray. It will pass undeviated. I need one more. Let's take one general light ray. What will happen? Inside this medium, it is going to bend towards normal. It is going to bend like this. It is going to bend towards normal. Okay. Now, for this observer here, this observer which is inside the slab, it is receiving these 2 light rays. For this observer, these 2 light rays seem to be coming from a point here. Okay. This becomes my apparent distance. Apparent distance d1 dash. Apparent distance for the first image here. What is image and what is object? For eyes, there is absolutely no difference. Eyes are concerned with light rays. Light rays are coming from image or object. Does not matter. Does not matter. Okay. So for this observer, object is actually here. For this observer, the observer cannot make out that the object is actually here, but it just appears to be here. No. For this object, for this person, the object is here. Here there is nothing, absolutely nothing. Because why? Because all the light rays are coming from this point. No light rays coming from this point directly to this person. All the light rays appear to be coming from this point. So for this person, this is the object. Object is here at O1. This is the apparent distance. This is known as apparent distance. It is going to be equal to clearly mu times d. Apparent distance is always, remember, apparent distance is always d over mu or mu times d, depending on the case. Here clearly, this is more than this, so it is mu times. Okay, that's it. Now, okay, now for this person, this is the light ray. Now this light ray is moving from denser to rarer medium. It is going to bend. It is going to bend away from normal. It is going to bend like this. Okay, and actually what happens is, this is the original direction. This is the incident light. This is the original, okay, well, making mistake, no. This was the original direction of my incident light. This incident light, okay. This parallel slab, rectangular slab, is going to introduce lateral shift. So the final incident light, final emergent light is going to be parallel to this original incident light here. Anyway, it is going to bend away from normal. Now this observer is receiving these two. So for this observer, object is not here. Object is not here. Object is somewhere else. Where? At the point where, from where these two light rays appear to be coming from. Okay. So this observer will retrace extend these two lines backward here. It's like this. So this becomes the position of object for this observer. Do you understand this? Just try to figure out what is the value for this observer. Okay. For this observer here, right, reflection is happening here. What is value of D? This D, this value is equal to mu times D plus T. This whole thing, this was mu times D, this is T. So for this surface here, where the refraction is taking place, the actual distance of the object. Now this behaves like an object for this surface. The actual distance is this, mu D plus T. What will be apparent distance? This is the apparent distance. Okay. This is the apparent distance here. What will be apparent distance? This is D2 dash. From this surface, understand, from this surface, from the surface where refraction is taking place, from this surface, this is going to be equal to mu D plus T over mu. This is D plus T over mu. Okay, you understand this? You understand this? I'm going to write it like this. Is equal to D plus T over mu. D plus T over mu. What is this? It is this whole distance. So the object is here. Finally, it appears to be here, to this observer. The object has shifted some distance. This is the shift in position of object. This becomes the apparent position for this observer. This is what we are going to calculate, and this is what we have to remember, and this is what we are going to use in all these cases. We are going to solve these problems directly using this result. Result I will remember. Okay, what will be this value, delta? Okay, so I know this whole thing. P plus T minus this. Okay, so this delta is going to be equal to this whole thing. This whole thing is D plus T minus. So this whole thing minus this thing here. This thing I know. Okay, it is minus D plus T over mu. D gets cancelled. What is delta? Delta is T 1 minus 1 over mu. This is shift in the position of object as seen by this observer here. It is shifting towards right. The shift is towards right. This also I have to remember. I have to remember the shift. This is the shift and direction. Okay, this is the shift in direction of incident rays. Rays are going towards right, shift will be towards right. In direction of incident rays. Remember this thing, and this is what we are going to apply to solve these problems. Okay? You understand this? Let's try to apply this thing here and solve it. And then from the next class, we are going to look at refraction, image formation from curved surfaces. Okay. This case here, delta is T 1 minus 1 over mu. What is T? 15. 1 minus. This is 3 over 2. 1 over mu is 2 over 3. It becomes 5 centimeter towards right. Okay, the light rays will go towards right. Through those light rays only I will be able to see the image. So the shift will be towards right. That means the object will, the object will appear to be here. This is 5 centimeter. Okay, you understand this? So from this surface, this is the observer. So from this surface, the actual distance of the object is 25, but for this observer it will appear to be at 20 centimeter. 25 minus 5, 20. Okay. Now here the shift will happen twice. Okay, here delta is delta 1 plus delta 2. Okay, it is equal to delta 1. Delta 1 is, you see, this is of no significance. This T is thickness of the slab. Whatever is the distance does not matter. Okay, so this delta 1 is going to be equal to 15, 1 minus 2 over 3. Okay, plus this is 20, 1 minus 1 over 2. That's it. So this becomes 5 plus this becomes 10, 15 centimeter. The object will appear here, shifted by 15 centimeter. Well, what do you think? That's how we do it. Okay? Now, next one. Locate final image. Locate final image. That is something which is tricky. That is something which is actually tricky. How to do that? How to do that? This problem. This problem. Okay, let's try to do this. Here, try to get the answer. First, let's separate it. Let's separate. We are going to do this problem in two methods. Let's see which method turns out to be easier, more useful. Okay. First is like this. First is like this. We are going to do it step by step. Step by step. It's like this. If I have a plane mirror, okay. If the object here is my object is at a distance of, let's say, 50 centimeter, okay, then I get my image at the same distance behind the mirror. 50 here, 50 here. This is for a thin mirror. Thin mirror. The mirrors that we use generally are thin. Very thin mirror. This is a thick mirror. This is 6 centimeters. A thick mirror. Where do I find the image? Let's see. Let's do it step by step. Step by step. Okay. It's like this. Step by step. You see, both, if you look at the problems carefully, both are actually the same problem. Not the same. Similar in the sense that here one surface of this slab is painted. Okay. Now I can assume this to be a combination of one slab plus one plane mirror. If I go and paste it here, okay, if I bring this in contact here, this reduces to this case here. Both are same. Let's see if you are going to get the same answer or different answer in both cases. What do you expect? What do you expect? Ask this question to yourself and get the answer to yourself and keep that answer to yourself. And let's see, here we are going to see if you are going to get the same answer or not. Okay? That way you can analyze. You can analyze, okay, what mistakes you are making. Where is the fault line? It's very important to discover the fault lines. Okay, this is my O here. This distance is 50. This mu is given 1.5. Okay, here also 1.5. Of course, it should be the same. 1.5. Okay, this is 1.5. 1.5. I want to find image. Okay, so ray diagram. Again, ray diagram. Take one standard, the easier one here, the normal incident one. Goes without deviation. Then it returns also. It is incident normally. Here also, here also. It will retrace from here. Now let's take one other one. One other light ray. What is going to happen to this? It is going to bend towards the normal. Like this. That's how it is going to bend. Okay. It reaches the mirror. Light ray hits this mirror. For this mirror, these two light rays, they seem to be coming from where? Somewhere here. Okay. So let me extend that. Let's do that. Okay, this is my, let's say, I1. Or let's say O1, that's fine. I can write it as O1. You see, there is no difference between image and object. Okay. If you enter inside a glass house, a perfectly made glass house, okay, perfect glasses are used. Look at yourself. Okay. You can never figure out where is the mirror. If the glasses are clean, perfect, chances are you are going to collide with one mirror or the other. Or in that mirror, let's say many persons are inside that glass house. You look at some image. I'm here in glass house. There are several other people together with me. I look in some direction. I see someone. I'm looking around. I'm looking in some direction. I see someone. Can I figure out whether the thing that I'm looking at is an actual person or an image? Can you answer this? There is absolutely no way of figuring out whether the thing that I'm looking at is an actual person or the image of an actual person or the image of an image. Think about it. Absolutely no way. Okay? For me, for my eyes, it doesn't really matter whether the rays are coming from actual object or an image. Both are same for me. Okay? I don't discriminate. What I am concerned with is only light rays, that's it. Okay? So now, for this mirror, these two light rays are coming from this point. This is the object. For this mirror, this object does not exist. Okay? If you go tell this mirror that the object is actually here, it is not here. Okay? You are in mistake. Do you think the mirror is going to agree? No, never. You will fight with it. Okay, so this is the 6 centimeter here. 6 centimeter here. Okay, what is going to be? What this is going to be? This is going to be mu times d. Mu times d. So 3 over 2 times 50. It is going to be 75 centimeter. 75 centimeter. From where? From this point. 75 centimeter. So for this mirror, this is the object. All the light rays are coming from this object. How the hell can you believe that the object is here? Absolutely no way of believing. Okay. So the object is here. What is the object distance? What is the object distance? It is 75 plus 6 is 81 centimeter. So now this mirror will create its image according to the object here. Okay. That means at the same distance behind the mirror. That means at the same distance behind the mirror. And how that becomes possible? It becomes possible because these light rays are going to be reflected like this here in this direction. In this direction. Okay? And then if I extend it, this is O2. Now this distance is going to be equal to 81 centimeter. Look at this. 81 centimeter. 81 here. So 81 here. But it will be from this surface. Now, again, this surface here. Okay? This surface here. Now for this surface, this, you see, this light is getting retraced. Now for this surface is receiving two lights, one light here and one light here. Now for this surface, these two light rays are coming from this point. So there is an object here. There actually is an object here for this surface, not for me, not for this, but for this surface. Only for this surface, there is an object here. What is the object distance? Okay, this distance from here to here. This is going to be equal to 81 plus 6, which is 87 centimeter. 87 centimeter. Okay, now the light is coming out. The light is coming out from this surface. It is entering into a rarer medium. Rarer medium, it is going to bend away from normal like this. Away from normal like this. And now if someone is standing here, okay, now this person is receiving this light and this light. Now for this person, this observer here, these two rays appear to be coming from this point here. So this is where this person will see the image. Okay. So what will be this distance from this person here? You see the distance has decreased. This apparent distance is smaller than the actual distance. Okay. So it is going to be, okay, divided by mu. So 87 divided by 3/2. Okay. So this is going to be like, this is how much? 29 times 2, 58 centimeter. Okay, 58 centimeter. So if I stand here, let's say that I replace this object, my object is here. If I replace this object with myself, if I go and stand here, if I am looking at myself in this mirror, okay, so from this surface, my image will appear to be at a distance of 58 centimeters. Not 50, but 58. Not 50, not 56, but 58. Do you see this? Okay. Do you see this? 58 centimeters. I hope that I made all these calculations correctly, and you are also able to see this clearly. It is focused well. I hope it is. Okay, you understand this? You understand this? All right. Okay, what else? What else we can do? Okay. It is 58. Okay, how come it is 58? Shouldn't it be smaller than this? Where from? Okay, it is like what do you think? Is this all right? Is this all right? Is this the correct way of doing this? Okay. let me think of one other method that I was talking about, and let me think if that will work here, or if that is even suitable for this case. So 4, okay, 54, 4, okay, fine. One other method, okay. You understood this? Now, 58 centimeter. Let's look at one other beautiful method. One other beautiful method. Okay. This is mirror. The silvered face of this slab. N. Okay. Let's say that I am standing in front of this mirror. I am standing here. In front of this mirror, this distance is 50 centimeter. 50 centimeter. This is 6 given. Just given. It's like this. I have this container, I fill up water. This is the actual depth. Now when I look at it from outside, this bottom appears to have been raised. It appears to have been raised, okay? Then the apparent depth is smaller than the actual depth. D dash is equal to D over mu. If I do not have this slab, forget about the slab. I just have a mirror. I just have this mirror. That's it. At what distance the mirror is? What is the distance? This is 6 centimeter. What is the actual distance of mirror from myself here, this person? Forget about the slab. Imagine there is no slab. This distance is 50 and 6, that is 56. But if I have this slab, this mirror appears to be shifted. Same thing that is happening here. Absolutely same thing that is happening here. Now instead of the mirror appearing here, it will actually appear here. This is where the mirror is going to appear. Okay. What will be this distance? This distance is going to be equal to 6 over mu. 6 over 3 over 2. It is going to be 4 centimeter. This is actual position. This is where the mirror is. But for me, mirror is here. There is shift in the position. This is the apparent depth. The actual depth of the mirror is 6 centimeter. For me, this depth is 54. So for me, you see, when this slab is perfect, you are never going to figure out whether I have one mirror or it is a slab plus mirror. Absolutely no way of figuring out. If provided it is okay, but if there is, let's say, some dirt, some dust, some grease and all that, some roughness in the mirror, then you will figure out that I have this slab, then I have this mirror. But if it is a perfectly made mirror, you are never going to figure out whether there is a slab here or not. You will just see this mirror at a distance of what? What is this distance? This is 54 centimeter. So you know optics, you know how image forms. So for you, where is the image? You will find your image at a distance of 54. This distance is 54 centimeter. Okay? Then what will be this distance? This is 4. This is 54. This is 4 plus 54. This is 58 centimeter. Same answer we are getting. Try to relate both. Side by side. Side by side. Try to find the underlying basic principle. The underlying thing that is at work here in both cases. Okay, now what about this? Here I am going to solve it using one method, the other method you try to figure out. Okay. This is object here. Now here we are going to make use of the thing that we derived, that is delta is equal to T1 minus 1 over mu. Okay, it's like this. I have this slab. I have this mirror, okay, and my object is here. Here is my object, okay. Let's look at this. Now imagine that this mirror is actually an observer. Mirror is actually an observer. Where this object will appear to be, where this object is going to appear to be 30 centimeter here and 6 and 20. 6 centimeter here and 20 centimeter here. There is going to be a shift, delta. Let me call it as delta 1. Okay. This is going to be equal to, so this is O1. So for this mirror, the object is actually here. Understand this? What is this shift delta 1? Delta 1 is equal to 6, 1 minus 2 over 3. Okay, mu is 1.5, 1 over mu. Okay, so it becomes 2 centimeter. In what direction? In what direction? In the direction of incident ray. Okay. Along incident ray. Okay, let me write it like this. Or not along. In direction of incident rays. Okay. You see, in some books it is written as towards observer. This is the shift towards observer. But then this towards observer thing is just sometimes misleading, because even if there is no observer, there is going to be shift. Okay. Okay. So for this mirror, the object appears here. Okay. What is this distance? What is this distance? Okay. A shift of 2 centimeter has happened. 2 centimeter. So 30 plus 6 plus 20. Okay. 30 plus 6 plus 20 minus 2. This is 54 centimeter. 54 centimeter. Okay. Now, so this image will do its job. This mirror will do its job. It's a nice image, nice mirror. It will do its job. It will create an image here. O2. O2. This is going to be 54 centimeter. Okay, where? From this mirror. From this mirror. Okay, do you understand this? You understand this? From this mirror. Now, this light ray, okay, I am here. I am looking from here. This is myself here. Okay. I cannot I cannot see this image. This is the image that is made by this mirror. If I look at the ray diagram is going to look something like this. Okay. This is my object here. Okay. Okay. So you see, it's like this. This is my object. Okay. So this light ray, this is my original light ray. It is actually going to be shifted like this. Okay, and it will come out parallel to this. This is causing this lateral shift. This is the lateral shift. Okay, the light ray from here, this is the object, this was my original object. It cannot reach this mirror directly. Before reaching this, I have a slab here. Because of this, there will be this lateral shift, okay, and the shift in the position is equal to this. This is not lateral shift. This thing is lateral shift. The light ray is laterally shifted. This thing is lateral here, lateral shift. Okay, so now the light ray will be reflected from this, and when I extend it backward, it appears to be coming from here. Light ray is reflected. Now, again, when returning, the light again has to pass through this slab. Light again has to pass through this slab. Okay, again there is going to be lateral shift and then the corresponding shift in this position. Okay, let's see how it is going to bend towards the normal like this. It is going to bend towards the normal. Okay, and finally it will come out parallel to this. Okay, finally this light is going to be parallel to this light. Okay, it is lateral shift here. Now if I extend it backward, okay, it is going to appear to be coming from this point here. This is O3. And this is the image, this is the object, this is where I will find my image. If I am standing here, okay, so I am receiving this ray which returns from the mirror, and this ray. And for me, these two light rays are coming from this. So this is my image. Now what will be this shift? What will be this shift? This shift here is also going to be same 2 centimeter, because it is the same slab, and shift is in direction of incident rays. Incident rays are towards left. The shift is also going to be towards left. How much? Same 2 centimeter. Then what will be this distance? What it will be? It is going to be equal to 54 minus 2. This is 52 centimeter. 52 centimeter. From where? From this surface. 52 centimeter. From where? From this surface. Didn't we get the same answer for the earlier problem? In the last problem, what was our answer? In the last problem, what was our answer? Our answer was like this. Okay. If you remember the answer, of course you remember the answer, I know. Okay. Okay. So this is my O. I was getting this O3 at what distance? This distance was 58 centimeter. Then what will be this distance? The distance from this silvered face, it is going to be equal to 52 centimeter. And both cases same. Exactly same. Exactly same. So no matter whether the slab is in contact or it is separate, you are never going to find out. You will always see your image at the same position. Okay, we understand this point. Okay, let's wrap it up with one question, last question, and then that's it for this class. Okay, let's wrap it up with one question, that's it. Okay, it's like this. I have this object here. This is my object. Okay, and I have this slab in between. Let's say that its refractive index is 1.5, and this distance is, let's say, how much? What do you think? Okay, 9, let's say 9 centimeter. 9 centimeter. Okay, this radius is, let's say, 40 centimeter. 40 centimeter. Okay, the question is like this. Okay, what is D? Okay, find D. Find D such that final image coincides with object. Final image coincides with object. At what distance the object should be kept? If I do not have this slab, then at what distance I should keep my object such that the image coincides? It should be at center. If object is kept at center, image is at center. But okay, in that case this D will be equal to 40 centimeter. What if I have a slab here in between? Then what should be distance? What do you think? Can you figure out? Can you figure out what is going to be the answer? Okay, spend some time with this problem. And now I know that you must have tried it. I'm going to discuss it. Okay, you can pause. Suitably, you can pause. It's like this. I have this light ray. We know that there is going to be lateral shift. Lateral shift. Light ray is going to bend here, and then finally it is going to come out parallel to itself. Parallel to itself. Okay, makes sense. Now for this mirror, if I do not have this slab, then this light ray will directly reach this mirror. The object is kept here, and the mirror will also think that the object is kept here. If I do not have this slab, but if I have this slab, things are going to change. Now this mirror will think that object is kept somewhere here because I am receiving all the light rays from this point. So there must be an object here. No amount of drilling will convince the mirror that the object is not here, but it is here. Forget about it. No amount of drilling will do. The object is actually here for the mirror. Okay? Now, if I want my image to coincide with object, the rays have to retrace. Light must retrace from some point. Okay? So, from this last reflecting surface, there is no other way to retrace. The only thing it can retrace is from here. So from here the light rays must retrace. And under what condition light retraces from a mirror? When it falls normally. On a concave mirror, in which case it will fall normally only if the light comes from its center, if this happens to be centered. So if the mirror thinks that this light is coming from my center, then I will send it back along the same path. Okay, that means this distance here. Okay, this distance to the mirror, the object must appear to be at its center. This distance should be 40 centimeter. And what is this shift? What is this shift? Okay, this shift is equal to P 1 minus 1 over mu. This is 9, 1 minus 2 over 3. This is 3 centimeter. And what is the actual distance? This distance is 3 plus 40. And this is our answer. This is our answer.